coded bit, the coded bit for the 0 and coded bit for the 1, that means C0 and C1, for the C0 and C1, for also 0 to, that means time instant 0 to 9. Okay, so we have to just process for other time instant up to C09 and C19. So this is the procedure how we will calculate the C0 up to C09 and C19. And at last we have got that C0, this is basically the code vector, that means C00, C01, C02, that means these are the value, that means this is the value of the C00. As you can see that C00 means code vector 0, code vector 0 at the 0 instant, that was 1. So this is 1. So this is C00 where j equals to 0. This is C01. You can see C01, what is the value was 0. So this is 0. So in this way we have calculated, or you have to calculate it from C09 and C19. So we have got these two coded or encoded bit sequence. Okay, these are total encoded bit sequence from one information bit sequence. Okay, so from one information bit sequence we have generated two coded bit sequence for C0 and C, so that means for the 0 bit and the 1 bit. So for the 0 bit, this is a code bit C0, and for the 1 bit, that means bit 1, this is a code, that means code bit for the 1, so C1. Okay, so for one information bit sequence, consider the information bit sequence. So for one input information bit sequence, we have generated, or we are getting two code sequences. That's what I'm just told to our previous pages, that at each time instant or each information bit, for the each information bit sequence, actually this will be the sequence. Okay, so or each information bit sequence, for the each information bit sequence, two code bits are generated. So the code rate will be 1 by 2. Okay, so that's the thing. Now go to the last part, that now you have to just consider, you just see that here the number of the code bit for the C0 equals to 10 bit. The number of the code bit, that means the bit representation, the number of the bits in the code bit for 1, that means for code bit 1, the bit representation is basically 10, because 10 bits are there. Okay, and for the C0, there is also 10 bits are there. So for the total encoded bit, for one input bit sequence, that means for one input information bit sequence, that means this, for one input information bit sequence where the bit number was also 10, we have got the total encoded code bit of bit representation of 10 bit, that means 10 for the C0 and 10 bit for the C1, so total is 20. Okay, so number of the information bit is 10 and code bit at the output is 20. So the rate is what? 10 by 20 equals to half. So this is basically the number of the information bit 10, the number of the code bit 20. Okay, so we have got 20 bits at the encoded form, and we were given the information bit sequence where the number of the bit was 10 also. So just dividing the information bit with the code bit, the number of the total code bit, we have got the half. So this is the half bit coder. This is also called, the convolutional code is also called the half bit coder. Okay, because the code rate is basically half, always half. The code rate is half. So this process is very laborious because, but this process is basically laborious because you know that you see here that for C0, that means for Cj, for C0j, okay, for the zero code bit of j instant, j is basically starting from 0 to 9 or 0 to n. So you have to calculate each time the xj minus 2. So this is very laborious job. So for C0j, C1j, C, so for the each case we have to calculate individually. Okay, so that's why, so number of the information, okay, the process is very laborious. So because each time we have to calculate, we have to compute the code bit, that means Cj. So we compute the code bit by using much more simpler process, or you can say faster way, by the state diagram. So we will see later later on, and from the coming lecture we will see that what is the state diagram application, what is the state diagram application to the convolutional code. So now for the information, you just remember it, that just take a note that we compute the code bit. Okay, we compute the code bits by using much more simpler process of the state diagram to avoid this laborious computational process. Okay, so this is the process to generate the output. Okay, example of the convolutional code output. So this is the process to generate the output. You are given an information bit sequence, then C0 and C1. So you have to calculate C0j for the j instant, and j is basically starting from 0 to 9 for this example only. Again, you have to calculate C1j. So for one information bit sequence, you have to calculate two code bit for 0 and 1 respectively. And this is the process. That means the expression for the C0 equals to xj xor xj minus 2. J is basically the present time instant, and j minus 2 is the previous time instant or the past instant of time. For the C1j, we are considering this expression, that means xj xor xj minus 1 xor xj minus 2. Okay, and you have to just replace the values, and considering x of, we have just considered two past values, that means x of minus 1 and x of minus 3. Actually this is a state diagram, so I'm just I've just told you the term state diagram. So actually this is a machine, so I've already told you. So this bit information is going to the encoder input, right? That means that encoder we have studied. So this is the encoder, that means from the previous note. So this encoder, okay. So the bit information, the message bit information is going to this encoder input, okay. And we are generating the output encoded code sequence actually, okay. So just coming to this point here. So here, as I've told you, the state diagram, and we have already studied that FSSM, the machine, the finite sequential state machine. So that basically is a timing machine. That means it's a timing machine. That means it control the timing, control the timing of the input bit sequence. So here, x of minus 1, that means this encoder consists FSSM. Okay, I've already told you, is a finite state sequential machine. Finite state sequential machine, that is FSSMS, are important part of the convolutional encoder. That means this encoder consists FSSMS. That means finite state sequential machine.